All right, so mercury reacting with an alkyne. A couple things to remember here. Mercury's a catalyst. Mercury 2 plus the catalyst, 2 plus the catalyst. So the mechanism is not done until we've regenerated that. And of course, we always remember that the nucleophile is a pi bond. We also remember that these mercury reactions, whether with alkenes or alkynes, always forms a three-numbered ring. And so it's concerted, meaning there's no carbocations. It's all done in one step. So that's the other big thing to remember that people often forget. When do we have carbocations and when do you not? Also, of course, be very, very careful with your bond angles. Careful with your bond angles here. Number of my carbons, again, to check. So it was pretty clear to me carbon 2 is more substituted. So in these mercury reactions, the solvent always reacts, the polar product solvent, on the more substituted carbon. Remember that Markovnikov addition? And this is an SN2-like. So make sure we get our bond angles looking good here. So we got mercury with the plus. We got a methyl there. Water. It's good. H. Now this is one of our favorite reactions to do, is that tautomerization. Those go there. So we just got done with our tautomerization. Too late to do that even. So what do we still have? We still have an enol. Well, wait, no, we don't have an enol. We just got rid of the enol, right? But what we do have is the mercury still on there. I have a plus charge. And so we know we gotta get rid of the mercury. And mercury's a metal, so the way to remember this is we want electrons to flow away from the metal, right? So the metal's willing to give up electrons, and the oxygen wants electrons, right? So let's get rid of the metal. The metal will go to 2 plus now. So now mercury has been turned back in, right? It lost electrons, so now it's mercury 2 plus. So we've regenerated our catalyst. And what else did we make? Well, looks an awful like to me, like an enol. All right, let's do a good job of numbering our carbons. Kind of got lazy there, Wenzel. 2, 3. 1, 2, 3. All right. So what do we need to do now? So we could either do a neutral conditions, right? We could do neutral conditions where this could tautomerize, or because we're in H2SO4, we can treat it like acid. Just say H plus. And we can do this. The pi bond reacts with that. And these electrons go there. All right, and this is a catalyst. So it's going to get regenerated because this H that fell off, it ends up being the new H. So there. And there's 3 H's here. And this H that fell off, I circled in blue, is the catalyst that's been regenerated. So you're done there. So you've done the whole thing. Things to remember: alkynes with mercury and water make ketones. Terminal alkynes with mercury and water make ketones.